Hello friends, in this video I will illustrate how you can analyze a conical pendulum that is attached to a double string system. So the problem says the figure shows a bob moving in a horizontal circular motion with an angular speed of 2 times under root 2g by h, where distance AV is given and that is equals to h. And we have to find the ratio of tensions in the supporting strings, that is T1 by T2. It is also given that the strings are of equal lengths and these strings are in-extensible. So let us plan how will you solve this problem. So what are the things that has been given? So you have been given this length, so this point is point A. So this point is point A and this point is point B, and this length is given. So this length is equals to h. And the length of a strings is also given, that is L, and both the strings are having equal length. So this length is L and this is also of L length. The mass of the bob is M, and let's say at this time this makes an angle theta with the vertical. And this mass M is moving in a circle, and the omega for this is given, that is 2 times under root 2z by h. And what we have to find? We have to find the value of T1 by T2. So we have to find this value. Now how will you solve this problem? So let us write equations of motion and try to solve this problem. So pause this video and do yourself, and after some time you see the solution. Okay, so now let us see how we can solve this problem. So first we have to write equation of motion. For that purpose we need to draw the forces diagram, free body diagram. So on this mass the forces acting is mg, and the tension force will act, let's call this tension is T1 in this direction, and T2 will act in this direction. So T1 has a component in this direction, this angle is theta. So in this direction we will have a force component T1 cos theta. Similarly, this angle is theta, so this angle is also theta. So in this direction we will have a component of T2, and this will be T2 cos theta. Now this is the radius of this circle. So along this line you will have component of T1 as well as component of T2, and T1 will be T1 sin theta and T2 will be T2 sin theta. So now we have written the forces. Now we can write equation of motion. So if you see the vertical direction, you will have T1 cos theta minus T2 cos theta and minus mg is equals to 0. This means T1 minus T2 cos theta is equals to mg. So this is first equation. And the second equation we can write, that is force towards the center, that is T1 sin theta plus T2 sin theta is equals to mv square by r. Or we can write m omega square r. So if you want, you can write in both format. So let us keep this in this format, mv square by r. Let's call this equation is 2. Now we have to simplify these two equations. Now what will the value of cos theta and what is the value of sin theta? So cos theta will be, in this case, cos theta is this distance divided by this distance, that is h by 2 divided by L. So this is basically h by 2L. What will be sin theta then? Sin theta will be this distance divided by this distance. So sin theta will be r divided by L. So now we can simplify these two equations. So from 1 I can write T1 minus T2 is equals to mg by cos theta, and cos theta is nothing but h by 2l. So 2l goes on the top. So we will have T1 minus T2 is equals to 2mgl divided by h. So let's call this equation as equation number 3. Similarly, I can simplify this equation, that is T1 plus T2 sine theta is equals to mv square by r. What is the value of sine theta? So I can write T1 plus T2 is equals to mv square by r sine theta. But what is sine theta? Sine theta is r by l. So this is mv square by r times r by l. So this will become mv square l divided by r square. Or we can write T1 plus T2. This is equals to m v by r whole square l. And v by r is nothing but omega. So this is m omega square l. Let's call this equation 4. In fact, we can put the value of omega here. So if you remember, the omega value is given in the problem. So we can further rewrite this equation, that is T1 plus T2 is equals to m, and omega is given, that is 2 times under root 2z by h. So this value is given. So m omega square l, so this will become m times 4 times 2z by h times l. So this will be T1 plus T2 is equals to 8mgl divided by h. So this is my equation number 4. Now let us divide equation 3 and equation 4. So these two equations. So equation 3 is this and equation 4 is this. So I can divide these two equations. So if I divide this, what I will have? This side I will have T1 minus T2, and this side we will have 2mgl by h, 2mgl by h, and here I will have T1 plus T2. So this will be, and division here I will have 8mgl by h. So this is 1 by 4. So now you can simplify T1 minus T2 4 times is equals to T1 plus T2. So you can have 4T1 minus 4T2 is equals to T1 plus T2. So this means you will have 3T1 is equals to 5T2. So T1 by T2 ratio is equals to 5 by 3. So you see, that is T1 by T2 is greater than 1 basically. And this is obvious because the upper string will have more tension, because this is also supporting the beat. The mg is going to that strings. That's why the T1 value is greater than T2. Now let us see, we have a question for you. So the same problem what we'll have in this case, now the same problem, but now this time this is attached by a spring and this mass is m and the spring natural length is same, everything is same. Now velocity omega is given in this problem, this length is L and this length is L, mass is given. Now you have to find what will be the elongation in the spring. So what will be the elongation in the spring? And the k value is given. So k value is given, both are having same k, everything is symmetrical, and this is again moving in a horizontal circle, something like this. So let us write in the comment box how will you solve this problem and what will be the value of elongation. So I hope you enjoyed this video, and if you enjoy, please share with your friends, and I will see you in the next video. Thank you.